Changing shadows. Objects such as people, buildings, and flagpoles have shadows on sunny days. That's because solid objects block the sunlight. Shadows give information about the position of the sun. What if you see your shadow in front of you? You would know the sun is behind you. Did you know a shadow can tell you what time of day it is? Here's how. Pretend you're standing in the picture below. You're facing south. North is behind you. It's 12 o'clock noon. The sun is in the south and overhead. Look at the shadow of the flagpole in illustration number 1. What direction is it pointing? If it's pointing straight north and it's short, when a shadow points north, the time is about 12 o'clock noon. What did the shadow look like at 9 o'clock this morning? Do you remember what direction your shadow pointed in the morning? Do you remember how long it was? Illustration 2 shows you a flagpole at 9 o'clock in the morning. The flagpole casts a long shadow and the shadow points west. But the shadow doesn't point straight west, it points a little north too. The direction between north and west is called northwest. What will happen to the shadow in the afternoon? By 3 o'clock in the afternoon, the shadow's long again. Illustration 3 shows the shadow pointing east. Actually, it's pointing northeast. The sun is moved across the sky and looks low in the west. In a few more hours, the sun will set in the west. Two things happen to shadows between sunrise and sunset. Early in the morning, shadows are long and point west. As time passes, the sun rises higher in the sky. The sun is moving from east to west. As the sun moves, shadows get shorter and shorter, and they point more and more north. At noon, the shadow is as short as it will get. It points straight north. After noon, the sun keeps moving across the sky. Shadows get longer and point more to the east. Just before sunset, shadows are very long and they point east. See how shadows can work like a clock? Here is a picture with several shadows and their times. All you need is a pole in the ground and a sunny day. Sun and seasons. Shadows can tell us even more about the movement of the sun. We know the sun moves across the sky from east to west every day. But did you know that the sun also changes position in the sky from season to season? Here's how you can prove it. Pretend you're looking at the flagpole again, but this time you're standing on the east side of the pole facing west. North is to your right and south is to your left. For this experiment, you have to measure the shadow at noon only, but you have to measure it every day for a year. Here are the noon shadows for just 5 times during the year. Look at the length of the shadow and the position of the sun in the sky on each date. June 21st, September 21st, December 21st, March 21st, June 21st. Sun position and shadow length at noon on 5 days during the year. On June 21st, the first day of summer, the summer solstice, the sun is high in the sky at noon. 3 months later, on September 21st, the first day of fall, the sun is lower. And on December 21st, the winter solstice, darkest day of the year, the first day of winter, and the sun is at its lowest noon position. After December 21st, the sun begins to climb higher in the sky again. On March 21st, it is as high as it was in September. 1 year after starting the experiment on June 21st, the sun is again at its highest noon position. The sun's change of position in the sky minute by minute during the day is predictable. The sun's position in the sky season to season during a year is also predictable.